So what we can do is we can look at statements and we can learn things about them by doing truth tables. What we need to do is if you have a statement like A, wedge B, parentheses, horseshoe T, or not T because we are using T's now, horseshoe Q, okay? And we have a statement like that, well, we can figure out in what situations this is a true statement and what situations. If A is true and B is true and Q is true, is that going to be a true statement? What if A is true and B is false and Q is true? And so we need to be able to do that. And so what happens is we do what we call a truth table. And what a truth table does is a truth table allows us to look at every possible combination where this is true, and this is true, where this is true, and that's false. This is true, that's false, this one's false, this one's false, this one's false, and so on and so forth. Now, one thing to keep in mind is that the book and the answers online and everything always, I have to check because I always have to remember which way to do it. They always do it in a certain way. The way you assign the truth or falsity of these letters really is not you can do it in a lot of different ways and it will come up looking different. If you were to make this like true, 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 and somebody else came along and made it false, 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 true, 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 and this one was false, 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 and you assign these letters truth and falsity in a different order, the truth table will look different, but the answers will be the same, okay? So I want to start off by saying that. But what happens is what you do is you take the number of individual letters, and if a letter is repeated twice, like if this said A wedge B, horseshoe B, then you have two unique letters. That B doesn't count as a new unique letter. And so what happens is if you have two unique letters, what you do is you do 2 to the power of n. N is the number of unique letters that you have in your statement or statements or argument. And so since we have 1, 2, we go 2 to the power of 2. 2 to the power of 2 is 2 times 2, which equals 4. Now, if on the other hand this was a Q, as we had originally, then we have 3 unique letters. So in that case, it becomes 2 times 2 times 2, which equals 8. Which means we need 8 lines of a truth table in order to show every possible combination of the truth or falsity of this statement. If we were to have a fourth variable, say this was Q plus L, then we would 2 to the power of 4 would be 2 times 2 times 2 times 2, which is 16. If we were to have another one, that's 5, 32. If we had another one, 64, 128, 256, 512, 1024, and we can get really fun at that point, right? 1024 lines. But what that does is it tells us how many lines we're going to need in order to look at every possible combination of truth or falsity. Okay? Now what happens is, let's just start off with our A wedge B horseshoe Q. What the book does is it always starts off and says, okay, we're going to need 8 lines. We have 3 letters. So we start off and we put true, false, true, false, true, false, true, false. The next unique letter we put, since we had 1 true, 1 false, we'll do 2 trues, 2 falses. 2 trues, 2 falses. And then the next unique letter we do, since we did 2 and 2, we'll do 4 and 4. 1, 2, 3, 4, and then 1, 2, 3, 4. If we were to add another letter, we would need 16 lines. So if we put parentheses plus L, like I said, then we would know the next one, we would be 8 trues, and then 8 falses. But this one would once again go down true, false, true, false, true, false. And that would give us every possible combination of truth or falsity for this statement. Now, what happens is we then do this where we say, okay, so true wedge true is true, false wedge true is true. The only time it's going to be false is if both of them are false. So this one's going to be false, and this one's going to be false. Then just for bookkeeping, we usually like to just put a little light line through it, not scribble it out, just enough that we don't look at it. And now we're going to say, okay, true horseshoe true is true. True horseshoe, true is true. True horseshoe, true is true. False horseshoe, true is true. True horseshoe, false is false. True horseshoe, false is false. True horseshoe, false is false. And false horseshoe, false is true. So, in this case, since this is our last line, we would just put a little box around it so we can draw our eye to it. We don't have to cross these out because that's nice for me with grading or you trying to check your work to be able to look back at that line and not have a line through it. But you circle what's there, and what you'll learn is you'll learn that in situations where Q is false, that unless A and B are false, it's going to be a false statement. And you can learn that from that. Now, this is what we would call a contingently true. The truth of this is contingent upon the truth of the letters within it. It's contingent upon the parts. But in some cases, what we'll learn is we'll learn that there are some times where no matter what happens, the statements will always be true. That if we have something like, let me just think here because I want to. Yeah, but that's too simple. So if we had something like A wedge B, or no, I'm sorry. That if we had something like bar A wedge B plus A wedge B, I don't know, this may be, I might have to look at this. Then what we would find is we can do this truth table. In this case, how many unique letters do we have? We have 2, right? There are 4 letters, but we only have 2 unique ones. So 2 to the power of 2 is 4. And so we know we start off with A being true, false, and B is true, true, false, false, which then the next one would be what? It would be true, false, true, false. What you need to make sure is you need to make sure if one of the A's is true, false, the other A is true, false, true, false. You cannot confuse these. This is saying that on this line A is true, on this line A is true, on this line A is false, on this line A is false. If you were to do and accidentally go true, false, false, then in this case, A is false on this line, true on this line. That doesn't make any sense. So you need to make sure these 2 correspond. Just as you need to make sure the B's correspond. Okay? Because you're looking at what the truth value is on that line. So the only time this is going to be false is when they're both false. So that's that one there. So the others are all going to be true. And then after we do what's in parentheses, we always do what's in parentheses. We always do bars in front of individual letters. We do what's inside parentheses. Then we do the bar in front of the parentheses. Then we do this because this is the main operator. And so the bar here becomes false, 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 true. And then what we do is we say true horseshoe, or true plus false is false, false plus true is false, false plus true is false, and true plus false is false. Meaning that in all of these statements, it's always going to be contradictory. They're always going to come to a false statement. Meaning this is a self-contradictory statement. Now, if we were to change this to a wedge instead, false wedge true is always true, and we find that's always true. And what we would call that is we would call that will always be true. And we have a word for that, and the word for that is what we call tautologous. And tautologous means always true. Now, what happens is there are things that we sometimes call tautologies, and there are statements that are tautologies. Like if I say A or not A, meaning it's either true or not true, well, that's always going to be a true statement. If I say something's either true or not true, well, assuming there is a truth value to be had on the thing, then it's always going to be the case that it's either true or not true. It's always going to be true. It's tautologous. Some fun tautologies. The most fun tautology is a statement that's always true. Is we have a statement like we can have a statement like people sometimes you'll hear people say, you know, it's always in the last place you look. You know, like they lose something, they've looked all over. I looked all over my house, I spent 6 hours looking, and you know what? You know, the thing I'm looking for is always in the last place I look. Well, yeah, that's true, and it oftentimes, you know, I mean, I realize what they're meaning by that is that, you know, usually it's, you know, it feels like I've done absolutely everything and it's always in like the last possible place I could look. But that's also saying, you know, it's also saying that if it's always in the last place you look, well, who in the world keeps looking after they've already been looking? I mean, if you find the thing, do you keep, like, suppose you lose your glasses tomorrow. Are you going to keep looking after you find it? No. It doesn't matter if it's in the first place you look. If you find them in the first place you look, you quit looking. And so, of course, it's in the last place you look. And so unless you keep searching after you've already found something, the thing will always be in the last place you look. It's a tautology. The thing will always be in the last place you look because you don't keep looking after you've found something. No person who's rational and reasonable, who's not suffering from a mental problem, is going to keep looking, right? And so that's a tautologous statement. It's a statement that's always true. It's always in the last place you look. Well, yeah, of course it's always in the last place you look. And so that's what we call a tautology. It's a statement that's always true. And some statements are tautologous, some are self-contradictory, and some are contingent. We can also use this to compare statements. And what we mean by compare statements is we can take two different statements and we can put them next to each other, and we can then evaluate in what situations they have the same truth tables and in what situations they have different truth tables. Like, for example, if I have bar parentheses A plus B, does that mean the same thing as bar A plus bar B? Well, we can do a truth table to find out. And what happens is we have two different unique letters, and so we would need 4 lines. So we start off with true, false, true, false. Then what we do is we can start on one side and do it, and then we'll do the other side. True plus true is true. False plus true, false is false. False plus true. Okay. One of you guys should have told me I was doing this wrong. Oh, I don't know why none of you spoke up. I'm really kind of hurt. I did true, false, and this one's true, false, true, false. But this one's supposed to be 2 trues, 2 falses. Okay. So true plus true is going to be true. False plus true is going to be false. True plus false is going to be false. And false plus false is going to be false. Then negate that. So true becomes false. False becomes true. False becomes true. And false becomes true. We go over here. We do the letters in front. So we go false, false, true, true. And false, true, false, true. And then false plus false is false. True plus false is false. False plus true is false. And true plus true is true. Okay, we circle that so we see what our main line is. Do the same thing right here. And what we'll find is that on the first line, they're both false. But on the second line, this one's true and this one's false, which means they don't mean the same thing. Because if they meant the same thing, they would have the same truth value on every single line. And in this case, they don't. They only have the same truth value on lines 1 and 4, meaning they're at least consistent with one another. They're not inconsistent, and those are a couple terms you can learn from reading the book, but they are not logically equivalent. Now, I'm going to stop this.